Hello there. I'm continuing the video series of complex numbers. So far we've talked about what are they, how do we graph them, how do we add them, how do we subtract them, and how do we multiply. Well, if we've gone through addition, subtraction, and multiplication, the next question is how do we divide them? Before I get into that, I want to get into this idea of a conjugate. And the conjugate primarily stems from a binomial term in which the primary rule, not the only rule, but the primary rule is that we take whatever sign is in the middle and we change it to the opposite. Now, this is different than taking the opposite of the number overall. So, for example, this first example, 1 plus 2i. The conjugate of 1 plus 2i would be 1 minus the square root of 2. I'm sorry, did I say 1 plus 2? I meant 1 plus square root of 2. So the conjugate of that is 1 minus square root of 2. This would be different. This is not the same as taking the opposite, because the opposite, and I'm going to write it up here, would be the negative of 1 plus square root of 2. And so, yeah, we get the minus in the middle there, but then the 1 would also become negative. The 1 starts off as positive and ends as positive. We only change the middle sign. So if 1 minus square root of 2 is the conjugate of 1 plus square root of 2, then what's the conjugate of square root 1 minus square root of 2? Well, we just change that middle sign to the opposite, so 1 plus square root of 2. So it's more to say that 1 plus square root of 2 and 1 minus square root of 2 are conjugates of each other. But let's get back into complex numbers. What would this look like for complex numbers? The idea is the same. 5 plus 3i, the conjugate is 5 minus 3i. 7 minus 2i, the conjugate is 7 plus 2i. Okay? And in negative 3 minus 2i, again, we only change the middle, so this would be negative 3 plus 2i. Now, I want to take the time to address an earlier video when I was rationalizing denominators, and I had a denominator that I rationalized by taking this and multiplying it by this behemoth right here. I believe once upon a time I saw that this was called a conjugate. Correct me if I'm wrong in the comments section. My understanding of a conjugate was that its main purpose is always to rationalize, to create rational numbers. And this certainly succeeded when I followed through with the math. But whenever I look it up, the only thing that gets referenced as a conjugate are these. So for this purpose, because I'm unsure, I will say this is a conjugate of a binomial. Okay, 2 terms. Is this a conjugate? Let me know in the comment section. All right, so now for the main course of this video, how do we divide complex numbers? And this is why I bring up conjugate. We are going to rationalize the denominator. So the current denominator, 2 plus 6i, is a complex number. It is not a rational number. We want it to be a rational number. More importantly, we want it to be an integer, okay? This is where the idea of the conjugate comes in. The conjugate's main purpose is to help us rationalize. So I'm going to multiply this denominator by 2 minus 6i. But again, what I do to the top, what I do to the bottom, I must do to the top, but also what I do to the top, I must do to the bottom. So it's 2 minus 6i. And so what I've created is 2 binomial multiplications. So I'm going to set up 2 different binomial squares. So 2 times 3, that's 6. 2 times a negative 1i, that's negative 2i. Negative 6 times negative 6 times 3 is negative 18, and that's I. And the negative 6 times a negative 1 is a positive 6, and that's an I squared. So let's bring all this together. I've got this diagonal right here is negative 18 plus negative 2. That's a negative 20i. And then remember this I squared here gives me negative 1. So I get 6 times negative 1, which is negative 6. And then this diagonal will simplify to nothing. Those will cancel each other out. So this numerator here is just negative 20i. Let's go ahead and do the denominator. 2 times 2 is 4. 2 times 6 is 12. And then we have the I. Negative 6 times 2 is negative 12i. And then negative 6 times 6 is negative 36. And then I squared. And then we go ahead and again, this becomes negative 1. And negative 36 times negative 1 is a positive 36. So now when we add our diagonals, notice this middle, the imaginary parts cancel. So this is just 0i. That cancels. And then when we get 4 plus 36, we just get 40. So we get a real part of 40. This is the best way because we've rationalized a denominator. We've got an integer. That's what we want. Now, if you notice, the shortcut was, and the purpose of the conjugate is that these two imaginary terms will cancel out. So if you want to create yourself a shortcut in the future, square 2, square 6, and then add them together. So 2 squared plus 6 squared is 36 plus 4, and that's 40. We can simplify this. Each get a factor of 20 to come out, so this is just negative 1, and this is 2, and I'll erase that. So negative 1 over 2, and that simplifies to negative I in the top over negative 2, and that is my final answer. If you like this video, go ahead and give it a like and subscribe, and leave a comment down in the section, and I will see you in future videos. Thanks for watching.